Hi, welcome to the November 16 meeting of the CNCF IoT Edge Working Group. This is a group that discusses supporting edge applications using Kubernetes and other CNCF projects. On today's agenda, we have got two items. We're going to start with an overview of Shifu, and then after that, we'll have a presentation on KCP Edge Multicluster. If there's time remaining, our usual practice is that we'll then open it up to additional topics if somebody wants to later add an item to the agenda notes document. If there are no items, we usually fill the hour just with birds of a feather open discussion. I just put a link to the agenda notes document in the chat. And with that said, I'm going to turn this over to, sorry, I haven't heard your name pronounced, but I'll give it a try. Yongli Chen. Yes. And he's going to tell us about Shifu.
All right. Yeah. Thank you so much, Steve, right?
Right.
Yeah. Okay. Yeah. And thanks a lot for the invitation from Kate. Yeah. Actually, let me share my screen. Can you guys see my screen now?
Yes, we see it.
Okay. Nice. Okay. Okay. So let's get started. And since we have two items on the agenda, so I will get this quickly go through this, and we can leave the questions later. Okay. First of all, thank you so much for the invitation. I'm Yongli Chen, and I'm the creator of Shifu. It's a Kubernetes native IoT development framework. Let me introduce myself first. So I was a Microsoftie. I used to work at AKS, Azure Kubernetes Service, for a few years, and before that I was working on the Azure Container Networking, and I was responsible for the Azure CNI and stuff. So I started working on Kubernetes since 2017, and I became a Kubernetes org member since 2019, and I'm a UIUC alumni. So if there's any alumni here, you are welcome to contact me. So talking about the main topic, so we all have a dream of ubiquitous interoperability for this IoT industry. So in the left, we have a report from McKinsey. So McKinsey indicates there are like nearly 40% of economic impact requires interoperability between IoT systems. So, and you can see the market value for it. The potential impact, economic impact of IoT is like $11 trillion, and 40%, nearly 40% of it comes from the interoperability. Yeah, so it's like a $4 trillion thing. And on the right, we can see organizations are increasing their expenditures in this IoT integration thing. So, and more than half of them are investing on a moderate level. So over 70% of participating organizations are making moderate to major investments to support their integration needs. Yeah, so that's a background. So what about her reality? So the reality is ubiquitous silos. So we can see from the diagram. So sorry, it's a bad drawing, but you get the idea. So you have all kinds of devices running in different protocols and connect to different IoT platforms. And on top of it, you can have like a different apps. So that makes up a silo. And between those silos, you can see there's no interoperability between the systems, platforms, and devices. So what's causing this problem? So the root cause from our point of view is the hardware vendors created those silos. And it leaves us software developers helpless. So we have to help ourselves to break those silos and write apps that can integrate or interact with all those different hardwares from different vendors. So how can we achieve that? There's an idea called structural virtualization. This is a made-up word. So let me explain. So what does this mean? So virtualization, we are all very familiar. It's like the virtual machine and stuff. You have all the virtualized computing environment. But this structural virtualization is more like treating the underlying device as a black box, and we only care about the input and output. So there's actually an analogy from Android. So you can see we used to have all those accessories like phones, like watches and cameras. And Android or iOS, the smartphone OS actually like did this structural virtualization thing and emulate them into apps and expose their capabilities as SDKs. So us software developers can actually write codes and actually we can invoke the capabilities from those hardwares very easily, right? We don't have to deal with the actual hardware. So that's the idea of the smartphone operating system and structural virtualization. We actually, so the rule of thumb is to virtualize all the hardwares into softwares. Okay, and then we have our product with structural virtualization under the hood. So it's called Shifu. So you can see on the left, you have different IoT devices, and on the right, you have those green lines of the virtualized devices. So we have a fancy name for them now. It's called digital twins, right? So what's happening here is like Shifu will create a digital twin for each connected device in the system, and expose their capabilities as APIs. So the traditional complex IoT app development will be simplified into like API heavy web development. Yes, and that's our idea. We want to make developing and like a industrial scenario as simple as developing an app. So Shifu has three main characteristics. The first one is Kubernetes native. And the second one is a containerized device integration. What does this mean? So basically, each of the digital twin is in the form of a Kubernetes pod. And the third one is declarative DevOps. Let me give you another, yeah. So here is a comparison of the before and after. Before this Shifu as a middleware, the developer has to deal with all kinds of underlying silos, right? But with introducing Shifu, you can have a middleware that abstract out all the underlying mess, and you only need to deal with the Shifu and not even Shifu. You already have the Kubernetes cluster, right? And Shifu actually virtualize all those devices as pods in your Kubernetes cluster. Okay. So actually, let me share. Give me a second so I can share the. Yeah. Oh, give me a second. Let's do this. Yeah, actually, there's a testimony from an early user. Can you?
Hi, I'm Kenyon Ethel, and I'm
Okay,
the lead robotics engineer and automation systems PM of LifeFoundry. At LifeFoundry, we build fully automated synthetic biology laboratories like the one you see behind you. To do this, we really need to integrate a lot of different IoT devices into our network. We build devices in-house as well as use third-party devices. And Shifu helps us integrate all these devices in a smart, efficient way. So with Shifu, we can treat all of the different devices as software objects and really abstract the physical layers so that we don't need to worry about the underlying connection and control of those devices. We can focus on building software on top of the existing infrastructure. This also helps us integrate devices in a smart manner. We don't have to keep reinventing the wheel and rebuilding our infrastructure for each new device. Shifu's generalized interface and easy expansion framework allows us to quickly integrate the huge variety of devices that we work with. So some of the devices that we integrate to our Foundry network include robotic arms like this, autonomous ground vehicles, and different both in-house and third-party lab equipment like centrifuge or dispensers. All these devices can be cleanly integrated using the Shifu framework. We are able to use the same underlying infrastructure across all these devices with only minor configuration changes. This helps us be very efficient in integrating new devices. Prior to Shifu, we'd have to rebuild our infrastructure for each of these, and it was very labor-intensive and time-consuming process. There's also a lot of different errors we'd encounter each time we integrated the new device. But with Shifu, everything is taken care of behind the scenes. We don't need to worry about rebuilding all this for each device. We can just reuse this very general and easy to build upon framework. It really accelerated our integration process for the numerous devices we have here at the Foundry.
All right, yeah. So yeah, let me give you guys a little background. So what's actually happening in their Foundry? So as you can see, they have like numerous devices, right? And they already have a Kubernetes cluster. They only want to run a single instance of infrastructure, so they don't want to manage all the infras, right? That's why they chose Shifu, and Shifu as a CRD just runs on top of Kubernetes, and you don't have to manage Shifu independently. Yeah, that's their use case. By the way, the company is called LifeFoundry. It's an Illinois-based synthetic biology company. Yeah. Now let's talk about something not so serious. Let's talk about why the name is called Shifu. I guess you guys have all watched Kung Fu Panda before, right? So Shifu is actually the little one on the right. His name in the movie is Master Shifu. Yeah. So Shifu actually means teacher or master in Chinese. So what does Shifu do? He teaches the student what to do. It's like here's a analogy. So we have the Shifu, right? And we have the Kung Fu Panda. The Shifu gives instructions to the student, and the student gives the Shifu feedback. And in our scenario, the structured digital twin or like a Kubernetes pod send the request to the actual device, and the device sends the response to the Kubernetes pod. And we have a jargon here. It's called a device Shifu. So that's basically the name for the structured digital twin. We're about to see it in the demo. Okay. Okay, let me show you a demo. So in this demo, we have a surveillance camera. So let me actually turn off the blur. Yeah, can you guys see it? There's a surveillance camera here. And the software, yeah. We have a kind cluster. So yeah, you guys can see my terminal, right?
Yes, we can see it.
Okay, nice, thank you. Okay, yeah, you can see now it's just like basically a fresh Kubernetes cluster, right? And we can just install Shifu with a single command. Okay, so basically this is the Shifu installation YAML, and this is a Shifu Git repo here. And we can see get pause -a. Okay, we can see the Shifu CRD system, the controller manager is running. Okay, so we can proceed to the next step. In this camera config directory, there are like total of 4 the Shifu related files for the camera. So it's kind of tedious right now, but we are trying to reduce it to 1. So let me show you the one by one. The first one is the camera edge device. So basically, this you can see it's a customer resource edge device, and basically you put the SKU connection address protocol stuff here, and the second one, which is the main one, is camera deployment. Here you have different 2 containers. So the first one is called the device Shifu HTTP. This one actually is like HTTP proxy, and the other one is camera and the camera Python image. So I'll show later about the code. It's a simple script which handles the RTSP stuff. Okay, and okay, and the config map and the camera services are just supporting files, and I won't show them here. Later, I will give you guys all the source files. Okay, let me proceed with the demo. Okay, now we can see it's deployed. Yeah. Okay, now we can see the actual device Shifu, right? The device Shifu camera deployment, and it's running. So remember what we have in the slide. There's the KBIS pod is called device Shifu here. So and the actual device is this one. Yeah. And okay. And now what I'm gonna do is I'm gonna forward the service out to my local endpoint. Okay, yeah. The service is a device Shifu camera, which is exposed, of course, from this pod. I guess you guys can see this, right? So now the local host port 3000 /info from here you can get all the camera related info. So what does this magic come from? So let me show you. Actually, let me go. So it's here. Yeah. So in this config maps, you have instructions, and under the instructions, you have info. That's basically if you fill up anything here, that line or that instruction will be exposed as an HTTP endpoint. So that's what's happening here. And if you do this, the stream, which is here, right? Stream, and you get this. I guess you guys can see yourself now. Yeah. So yeah, that's a basic idea, and let's proceed with the presentation. So yeah, so far do you guys have any questions?
Yeah, I dropped a few of them in the chat.
Okay.
I can read them to you now just so it gets in the recording. So I'm
Okay, yeah.
wondering how this compares to some of the other existing open source projects in this edge device space. Specifically, ACRI is a CNCF project that discovers devices and enables you to use them. There's a project, the rest of these are under Eclipse, but still open source projects. Hawkbit takes on software updates. Ditto is device twins. Hano would be device connectivity. And then Canto is a stack that I believe integrates a bunch of those into a wrapper for hosting containerized apps at Edge. Does this overlap those or work with them, or what does it, if it does some of the same things? I'm curious as to what different approach it takes, or why this somebody might want to look at this versus the other ones out there.
Yeah, actually, the idea where the Shifu is different is that Shifu actually wants to encapsulate all the device related stuff in a container. So that's why we call it structured digital twin. So we want them out of your application. So if you have an application, you should just contain your application code and not all those like infra level stuff.
Okay, is it Docker container specifically then? And if so, is this tied to Kubernetes or is it agnostic? So in other words, suppose I'm using Docker containers, but not the Kubernetes orchestrator. Does that work or not work with this? And if it does require Kubernetes, does it have to be running at the edge or can it be running at a higher level control plane, say in a cloud that isn't at the edge?
Yeah, actually, that's a great question. So Shifu right now is Kubernetes CRD, so it has to rely on Kubernetes, but it doesn't have to be run on the edge. So on the edge, you usually have like K3s or something like OpenEarth. But in the cloud, maybe you have full-fledged Kubernetes. Both of them work for Shifu. Shifu only requires running Kubernetes distribution.
Now, what happens if I'm running Kubernetes at a higher tier and my uplink gets temporarily broken? What happens then? Do operations stop or can they survive even things like a power cycle with recovery even when the internet link is down?
Yeah, so usually in that scenario, we recommend you guys to use like a KubeEdge or OpenEarth for that. So they have some sort of like offline capabilities. And if Shifu runs on top of them, then Shifu will get some of the offline capabilities as well.
Okay. What about safely keeping secrets? You know, I suspect some of these devices might have credentials and things that you have some concerns about them being unencrypted at edge locations without physical security. How does this, to the extent device credentials are required, like, you know, accounts or passwords to get connectivity to a device or encrypting a data stream, how does Shifu try to manage that in any way?
Yeah, so actually, that's also our concern as well. So first of all, this is Kubernetes native, so you can reuse all the cloud native technologies. So a lot of them, the problems are already solved. Secondly, so what we're trying to do is we are trying to integrate all those like key vault kind of service into Shifu. So maybe you can rely on the cloud providers key vault in the future, but right now we are relying on Kubernetes secret.
Okay, and then Kate, I think you had a question if you want to step in and ask.
Yeah, I have a few. So one thing I'm curious about is, so it looks like looking at your doc, you have several supported protocols. Do you define the digital twin interface for each of those protocols?
Actually, no. So I can show you the code for the camera later. So actually, this is the camera runs on RTSP. So it's actually like device dependent, and it's up to the developer to expose the interface for that.
Okay,
Basically.
that makes sense. And I don't know if we'll have time for kind of digging in much deeper because we do have another presentation today, but I'm personally very interested in that. I've worked on the Ocri project. I'm the main maintainer for that. And I do see this integrating well. What Ocri does is it discovers the IoT devices on your behalf and then can deploy workloads for you. And so, for example, Shifu's virtualized devices, those containers act explicitly as brokers would. And instead of having to, it looks like in your docs, say exactly this is that device, this is its endpoint, this is its credentials, instead Ocri would do that. So I think it integrates really well. And one problem we've had with it is how do you define that digital twin interface generically so that then you can have this API for interacting with a generic device of a certain type. So I think it'd be really cool I personally want to hear more about it and dig deeper. And I really enjoyed your presentation.
Yeah, thank you so much, Kate. And okay, then probably I will skip the architecture part. This one is like, if I have 1 hour, I'll dig into it maybe.
Maybe you can sign up for a follow-up at a future date, but yeah, we want to give some time to the other presenter, but you're welcome to have a deep dive,
Yeah.
second tier if you want at a future meeting.
Yeah, sure. Thank you, Steve. And okay, and this is the roadmap, and we already go through a bunch of questions. So here is the community info. So basically, we use Discord for our community, and it's just established. You guys are welcome to join, and we're gonna share the deck in our Discord, and also all the files used in this demo. Yeah, so basically that's all my presentations, and thank you guys for listening.
Okay, thanks. One final thing, maybe you can just answer this offline in the agenda notes doc, but I'm curious about the background of the organization behind this, the Edge Nieces. So maybe
Okay.
if you can fill something in about that for
Yeah.
people like me who are curious, that'd be great.
Of course, yeah, sure. Yeah.
Oh, okay, let's move on then to cover our second topic on the agenda, the KCP Edge, if somebody wants to take over and start that presentation. Go for it, Andy.
Okay. Can you all hear me?
Yes.
Yep.
Okay. Just looking to see if I can find. This probably should work. Let's see. Oh, I have to grant access. Excuse me. All right, I have to quit and rejoin because it needs access to my desktop. Apologize. Be right back.
Okay. While we're waiting, Yongli, maybe you can answer the
Yeah.
Edge Nieces question.
Yeah, sure. So actually, that's an interesting story. So back when I was at Microsoft, Brendan Burns was my boss, and I talked to him a lot, and and back then the Microsoft's strategy went from mobile first to cloud first to intelligent cloud and the intelligent edge. And you can see the mobile is dropped, and you have intelligent edge coming up. So that's why I dig into this edge computing thing. And after talking to Brendan a lot, so I came up with this product. And I can give you guys the story later in details. Let Andy start. I think he's back.
Okay.
Yeah.
Yeah, I'm back. I'm just trying to find the window now. Let's try this. No, let's not do that.
If you're new to Zoom, it's at least on my client, it's center bottom to share.
Yeah, I got it. It's just a different layout. Apologize for that. I usually tease the people that work for me that when they don't know how to do WebEx sharing, and I just got a taste of my own medicine there. Apologize. Hi, everybody. Thanks for having me. I have a few other folks on the phone that are with me. Paulo and Gosha Steiner are joining me on behalf of the KCP Edge project. We're excited to announce November 1st. We were announced as a sub-project of KCP. Are any of you familiar with KCP and what it's all about?
How about if you give us a quick summary?
Yeah, okay. Yeah, so KCP is intended to take what are normal Kubernetes tenants for doing state-based management and really just slim down the API server to be very, very small, can be run in a binary, as a matter of fact. And so it strips away a lot of the weight that comes with a full-blown Kubernetes cluster and allows you to run very small API servers wherever you'd like. And so what we saw this as a possible way to incorporate some of the edge use cases that we've been examining. Our day jobs are with IBM Research, And so we've been partnering with Red Hat internally, because Red Hat is an IBM company, to build upon what they've discovered in KCP and the traction and adoption they've been seeing in their project. And so our specific use cases have to do with, disconnected operations, as you pointed out, with Shifu, scalability, large numbers of objects on the order of 1 million or more, which would be represented by edge clusters. And then also, constraints in those clusters, right? They could be running on as small as, let's say, a Raspberry Pi, or, some other, a Jetson Nano or something to that effect. And so what we believe is there's a trend taking place in the industry whereby, lots and lots of these objects and these clusters exist today, but there's a real challenge when it comes to managing them. And so that's where we're starting to focus in on. Any questions so far? All right, so this is our project. It's part of KCP Dev. You can find us simply by going to KCP-Dev in GitHub and then look us up as the Edge-MC or the Edge Multicluster project. And you'll see very quickly up front, some of our objectives have to do around supplying a way to organize hierarchy, have some runtime interdependence or independence, being able to run operations independently of having connectivity to the root node. And of course, large numbers of destinations for where you can deploy workloads. So we feel that, all of these concerns and these goals that we have, there's a number of different ways that we can stretch and pull the KCP orchestration engine that's been built. And so what we're doing in that area is where you see under areas of exploration is changing the way placement is defined. And so today in KCP and in Kubernetes, you can address clusters, but you can't do that in such a way that you could say this set of clusters gets this set of workload and do that at scale. Of
Hey,
course,
Andy?
you have, yes.
Do you want questions as you go along, or should I save for the end?
Yeah, I'll pause. I'll try to pause naturally, but
Okay.
if you feel a sincere need to interrupt, please do.
Okay, I just had one about offshoot before I forget on your packaging up the Kubernetes API to run at large scale on low resource environments. Are you anticipating then that each of these edge nodes does host its own Kubernetes-like API? Is that the target here?
No, I don't think so at the actual edge location. So the edge location to us could be a single node OpenShift, could be an OpenShift, could be a Kubernetes cluster, could be a kind cluster, could be microshift, anything that can speak kube or kube, and can be kube style managed. That's what we anticipate to have at that edge. So it doesn't have to be KCP per se. It can be anything.
Okay.
All right. So in the areas of exploration, we're talking about things like how to customize those workloads, such that, as to manage 1 million edge clusters at scale, multi-cluster, multi-vendor, et cetera, there'd be different parameters, different secrets, different configurations that need to be rolled out to those different destinations. So how do we get the ability to fine tune and control that, but yet not overwhelm the developer and the operator at the same time to have to be able to manage each one of those 1 million or more individually, right? So that's a real kind of give and take. It's a push and pull there, the exercise that we have. We're talking about scheduling, also rollout control. And of course, two of the big elephants in the room here have to do with something that Kubernetes today isn't so good at, is status summarization. So if you tried to retrieve status from 1 million different objects and then interpret and use that information, you'd run out of time in the day, the year, the month, whatever, insert your time frame here. So status summarization is something that we feel is going to be a significant challenge for us, as well as etcd. So it's really no secret, if you've been working with Kubernetes long enough, is that etcd really is kind of an Achilles heel to Kubernetes and doesn't allow you to scale either the size of individual objects or the number of objects stored. And so we're experimenting with different ways that we can in KCP proper, and eventually into Kubernetes upstream, that we could use a different database technology there. One of which we're working with right now in KCP's community is Cockroach, because it has has support for time series. So all of those we're working, it's a combination of KCP work that we're doing in the open source and KCP Edge. We have a project board where we're doing a whole bunch of work. Now we've just started in November, November 1st. And we've got a number of investigations underway, and we're looking for more members to join the community. So I thought we were kind of birds of a feather here, fellow constituents looking out for edge use cases and how to manage them at scale. And so I thought it might be a good idea to give you a preview of what we're doing, and give you a little bit of a formal, informal invite to come join us if you'd like, and be part of this movement. So I'll take questions if you have any. I just wanted to give you a preview. Didn't want to overwhelm you with too many of the deep down technicals at the moment, because we're just getting started.
So, from my perspective, so how does this KCP in general differ from the open cluster management? So,
is anybody else having trouble hearing Dejan? I'm having difficulty. His voice is breaking.
Yeah, it's not just you. It's breaking
Okay.
up a little.
Can you hear me now?
A little better.
How KCP relates to the open cluster management initiative? I mean, is it a similar domain, or is it trying to solve a completely different use case?
Yeah, I believe it's similar in some aspects, OCM and what it was intended to do. And so this is sort of some of those same principles, same ways of same attempts at solving them, some of the same approaches, but some differences. So I don't have to point to, but it is somewhat similar. I know Paolo's on the call, so Paolo, if you'd like to expand on that at all, feel free to jump in.
Yeah, I realized that maybe it would be helpful in this context to give a little more intro on the KCP and the current sub-project also that is dealing with multi-cluster in KCP that is called the transparent multi-cluster, because KCP is already providing some support for distributing workload to multiple clusters that is called transparent multi-cluster. And so we sort of starting from there, but we realized that there are gaps and there are things that don't really work too well in the context of Edge. And that's why we thought we need basically another sub-project within the KCP organization to deal with the specific Edge problems that Andy was mentioning. And so in a way, we are starting from an approach that is more KCP-centric. This idea that compared to some open cluster management is more really following the current model in KCP, where essentially you can, for example, for transparent multi-cluster, you can, for example, create a placement, and then you can deliver a namespace resource in a namespace, and that is transparently synchronized back to some cluster in the backend. So you don't really have to really think about wrapping resources or adopt resource, different type of APIs. It's really a way to sort of give you this kind of virtual model where you can directly interact with kubectl the same way you interact with a regular Kubernetes cluster in this kind of virtualized model that is the workspace. So we're pretty much following that approach. And I have also to say that there is some work also going on with the open cluster management. Some of the folks, they are also working on KCP. Actually, some of them work actually on the KCP transparent multi-cluster feature. So I think there is collaboration between these two projects. And I guess the goal is also to evolve somehow both of them in a way. And potentially could be that at some point even open cluster management may even use some of these capabilities from KCP, but that is probably longer term kind of goal.
Thank you. Does that help, Dejan?
Yeah, makes sense.
Thank you for your question. Any other questions I can help? I can also, and I'll just point out.
I think you had one in chat from Prakash. It says any specific group of API being shunted out in KCP.
Yes, there's a limited set of API at the KCP API machinery level. So you have things that have to do with, you have APIs that are specific to a workload distribution and not much else, right? So the addition of others is, you can have that at any other layer in that, in the hierarchy that you build, but not specific to anything else but workload. There's a few others as well. I think there's 3 or 4 in total. But yes, that's how they slim down the API machinery.
So you slim down by taking off some of the APIs which are not so relevant. Put it that way, in a simple way. At the same time, I want to know that you do have to deal with the kubectl, right? Agent. So
yes, Cuddle is still fully supported. Yeah.
So if can a cluster, system cluster, which is external, and this being the target cluster, with those additional APIs, will they still be able to use this specifically? I mean the source and the target. Let's say master is source and target is what you have with the agent, which you have with the lesser API.
Right.
Yes. There is no disconnect between the two. How do you see if?
Yeah. So for go
Go ahead.
Sorry, we have a little delay on the phone. Go ahead and finish.
Yeah, the only thing I wanted to know is there any mismatch if there is API not being supported with being supported types, right? So a API expects something and it doesn't get. So how do you handle that error situation?
Right. So if you were to pull back a resource with kubectl, it'll give you the normal response that there's no resource available for that specific type, right? But then when you go to deliver a workload, when you say, let's send a deployment down to an edge cluster. Once you send that edge cluster down, they use what are called sinkers and sync targets. So sync target identifies what the location of where that sinker or where that sync target is pointing at. That's that edge location, that edge cluster, the physical cluster, if you will, or the physical edge cluster. They call them P clusters. So the sync target is associated with that. And then the sinker itself takes the package that is sent to it and says, okay, I have deployment, I've got a config map, a secret, I have to deploy it here, and then has the full support of the kube API that's running at the edge cluster to go ahead and deploy it. So we have also bumped into situations where we want to send something down, let's say a cluster scoped API or something else that's not supported by KCP out of the box. And there is the ability to adapt and change the sinker and the sync target such that we can support other API types, as well as being able to add that to the KCP out of the box and say, well, we need support for X, Y, and Z API. So it is flexible and extendable. And so part of our mission here as KCP Edge is to figure out, working with partners in the CNCF, some of which like Argo, Flux, in the application lifecycle management space, and then others in like policy management, like Kyverno and others. We're trying to figure out what are the common bits and API specs that have to be supported for them to be able to be deployed and used at scale at the edge. And so some of those have fallen outside the scope of what KCP supports today, and that's why our community exists. We'll be creating support for those things as we find them. There's also the option to wrap these things in sort of a manifest, right? So you're familiar with Helm. So taking things like a Helm chart or overloading a config map and then sending that down and letting that on. And so those are other approaches that we're experimenting with now. And we actually have a discussion that's queued up as part of the next community call, which we'll have this coming Thursday, where we are introducing how would we do the scheduling and what API types would we support. So your input would be valuable there, Prakash.
Mhm. Sure. I will.
Yeah, if
I
I
will
may
read it
add,
myself.
if I may add, there is also another feature of the schedule of the current syncer in KCP that we are, in a way, we're also using. That is this ability of import APIs from target clusters. So basically, even if the API is not on the KCP API server, basically in KCP there is this notion of workspace that is like a virtualization of the API server. So by default, it may not have all the APIs that you have on the target, but you can actually import these API definitions like CRDs, etc., from the target clusters. And they will be available now on the KCP workspace side. And then you can start creating instances of those APIs, and they will be propagated back to the target cluster. So this is a feature that is already part of KCP. As Andy said, currently there is very little support for non-namespace type of resources, but we expect also to work on some of those that we may need for edge use cases.
So Edge workspaces, just to add to that, how do you do the namespacing? Is the namespacing at the top level, or you have something clustered? See, you have to have namespacing as the top level, if I'm not mistaken.
Workspace is actually a new concept that KCP has introduced. It's really basically this idea of virtualizing the API server in workspace. From the point of view of a user, a workspace looks like a Kubernetes API server. So you cuddle into a workspace, you can create namespaces within that. You can apply RBAC, you can do cluster scope stuff, and it's completely isolated from other workspaces for other users. So that's pretty much the way it operates. So within the hierarchy is pretty much within a workspace, you have namespaces. It looks exactly like a Kubernetes cluster. And the structure of namespaces, when you sync to a target cluster, is replicated in a way to those target clusters, even if there is some name mangling to avoid collisions, other stuff like that. But pretty much namespace resources that you have on the workspace will be replicated to the target cluster within new namespaces that are created by the syncer agent on those clusters.
So is that the reason you have to have something like a cockroach DB for replication and all that to maintain besides the what you call the time series database, which you mentioned earlier, or one of you mentioned earlier?
It uses either etcd or cockroach DB. The database discussion is separate, and that's why it's being handled at KCP proper and not in the Edge MC specifically. So in our repo, in our community, we're not handling etcd and CRDB interchangeability, but we are reliant on the fact that, you know, to operate at scale, that specific dimension is going to have to be solved, right? So we're working closely with KCP to figure that part out, as well as sharding and API priority and fairness. And those are all, you know, separate requirements that we have that will eventually we will rely upon to have full scale. So it's a coordinated effort between the KCP community and the Edge MC community to solve those.
Fantastic. That's good to hear.
So folks, that wraps it up for us. Unless you have other questions, happy to stick around and field them. Scan the QR code, it'll take you over to our repo, or you can just go to, we'll soon have an investigation listed under KCP.io, or just look us up at edge-mc on GitHub. And like I said, our second inaugural meeting will be this Thursday, 10 a.m. Eastern. And we'd love to see some of you there. If you're interested, and get involved, roll up your sleeves, and help us figure this out. We're in the design phases, and we could use all the help we can get.
Sure.
Okay, thanks, Andy. We've got a couple minutes left if anybody wants to make any last minute comments. By the way, thank you, Young, Lee as
yeah.
well.
Yeah, actually, I have a question. So I already sent it in the chat. So what's the recommended cloud and edge communication method for this Edge MC? Is this some sort of VPN or polling?
This is usually, we're relying on pull. So as, you know, we're not doing push from the top down. So it's all pull. And then at some point, you know, having the ability to interchange API machinery closer to the edge may allow us to actually have, you know, separate communications happening at the lower portion of the hierarchy, such that they don't have to have direct access to the root at all times. And so that is where we're looking at supporting disconnected operations, is that having multiple levels of hierarchy.
Oh, okay, great. Actually, is it in some sort of design doc?
Yeah, we'd be happy to share it with you. Join on the community, and we're starting to design it now, so you can be part of that discussion.
Okay, sure. Actually, I already started the repo, number 5.
Awesome. That's awesome. Yeah, so we know we have a lot of common, you know, common goals and challenges amongst the two. So I think what we'd like to do is, you know, keep you informed of our progress over some kind of cadence, and we'll try to be diligent about that. I'll keep in touch with Dijon.
Great.
Okay, well, thanks, everybody. So next meeting is scheduled to occur in 2 weeks as usual. So far, well, I haven't even opened up the spot in the agenda notes doc to have to allow you to enter it, but I will. So if anybody wants to present at a future one, or even if you're curious about a topic and you want to challenge the chairs of this group to go find a speaker, go ahead and put something you're curious about on the agenda at a future meeting, and we'll do our best to try to line that up. So thanks, everybody. See you next time.
So, thank you.
Thank you.
Thank you. Bye.
Bye.